a diverse international community of more than 13,000 scholars. The American Physical Society is celebrating 125 years of connection and collaboration across academia, industry and major labs. From the City of the Lakes, the APS March meeting gets underway today. Welcome to the beautiful city of Minneapolis and the 2024 APS March meeting. I'm your host Stephen Horn and I'm delighted to be here. But I'm even more delighted to be joined this year by Audrey Godfrey.
That's right, Stephen. I'm so excited to be here. This is a first for APS TV. We are both here hosting to bring you more scientific breakthroughs, dive deeper into the latest research, and introduce you to even more leaders in the field of physics. It's a very busy week ahead, but Stephen, you've already been very busy making headlines of your own with a very impressive interview.
This was an incredible opportunity, Audrey. I loved it. I got to travel to Sweden to sit down with Nobel laureate Anne Lehoulier to discuss her research into attoseconds. That's right, attoseconds, 1/1000th of a billionth of a second.
I won the Nobel Prize because I contributed to the discovery of the phenomenon that is used for the generation of this attosecond light pulse.
Straight ahead today, you'll hear more from one of the winners of the 2023 Nobel Prize for Physics about attosecond pulses of light.
I can't wait for that. And plus, getting to travel to Sweden for that interview.
Across the bridge, Audrey.
Pretty sweet. Not a bad day at the office. Incredible. Well, it's a pretty sweet way to start off the week here at APS. We will also be sitting down with the APS March meeting chair to hear all about what's in store for attendees this week.
This is my 55th March meeting. If anything, they're more exciting.
And Audrey, yesterday was Squishy Science Sunday, right?
Yes.
I can't wait to get our hands dirty with the hands-on workshop.
Stephen, this was actually an event for kids, but I think this might be the type of physics that maybe I can understand. We'll have to see. We'll check it out. And also today, we kick off our tour of the universities and the institutions that are blazing new trails in physics research. Today, we will find out what physics urbana style means.
We packed so much into this very first edition of APS TV at the 2024 March meeting, and we want to make sure you don't miss a minute of it. Now you can watch the programs right here in the Convention Centre, on the in-house channels at several select partner hotels, on the March meeting website and on the virtual platform, on the March meeting app, on our YouTube and X social media channels, or you can scan the QR code right here. We get started on this fascinating first day with my sit-down interview with Nobel laureate Anne Lehoulier. As we mentioned, I had the opportunity to travel to her home lab at Lund University in Sweden. There we discussed her award-winning research of attosecond pulses of light. Anne, welcome, and thank you ever so much for having us here in Lund.
Thank you.
So, Anne, let's go back to the beginning. What got you started in physics? What was your motivation?
I think I have been thinking about physics and mathematics at a very young age, so I don't really remember. I had scientists in my family, so maybe I was a little bit inspired by my ancestors, but this is simply something I like to do and I continue to do.
I should say absolute congratulations, of course, for winning. I'm sure I'm the 100th person to offer you those.
More than that.
Those congratulations. But what went through your mind when you got that phone call?
Well, I can tell you that the only thing that went through my mind was, how am I going to continue my lecture? I had 100 students waiting for me, and but it has to be secret, 1 more hour. Getting the Nobel Prize, I simply didn't have time to think about it.
Maybe you could tell us just a little bit about attosecond physics and what you won the award for.
Well, attosecond physics is the science of generating very, very short light pulses in the attosecond range and using them for in particular for studying electron motion in matter. And I won the Nobel Prize because I contributed to the discovery of the phenomenon that is used for the generation of this attosecond light pulses, which is called high-order harmonic generation. So this was back at the end of the 80s in France. We were looking at the emission of light when atoms are exposed to a very strong laser field. And instead of seeing fluorescence light, which was the goal, we saw very high order harmonics of the laser field. And this was unexpected and extremely fascinating. Then a few years later, it was conjectured that maybe in the time domain, this high order harmonics would make a very, very short light pulses, a train of attosecond light pulse. And this was measured experimentally, actually 14 years later in 2001 by my two co-laureates, Pierre Agostini and Ferencváros.
So, and in Minneapolis, a lot of young people starting their careers in physics. So what's your message to them?
Well, my message to them is that it's a great career. So if they like to do physics, if they like research, if they are a little bit passionate about it, I think that's important. They also need to be stubborn to be able to continue in spite of difficulties. I think they should just go for it. It's a great job.
That's great advice. Now, my final question, as always with these type of interviews, is an impossible question. So it's the APS's 125th anniversary. Looking forward to the next 125 years in physics, what do you see?
Well, this is a very difficult question. I don't know the answer. But what I think I discovered during the 40 years of my career is that we discover more things, but there is even more things we don't understand, and we should try to understand. So, and also I really believe that science is going to help society to solve big problems, for example, climate change. So I think it's really important to, I think there is a lot to do in science and in physics in particular.
Well, thank you very much indeed for that. And thank you so much indeed for joining us. We really appreciate it. Thank you.
Thank you.
What exactly is physics urbana style? Let's check out the Department of Physics at the University of Illinois to see what cutting-edge science in the urbana style means.
In the Department of Physics at University of Illinois at Urbana-Champaign, we're driven by curiosity about the universe at all scales, so from subatomic particles to devices with many atoms, all the way up to the cosmic scale. And we're doing all of this research in a highly collaborative, interdisciplinary, and supportive community.
The Department of Physics here at Illinois is a very vibrant university. There's lots of people in different areas of physics. And one nice thing about being in the Midwest is that I think people end up working much more together. And this is not something that you see a lot at other departments. And so this kind of friendly work environment makes a huge difference here.
One way to describe the Department of Physics is summed up in our concept of what is known as the urbana style of physics, which is a highly collaborative and interdisciplinary approach to doing research as well as teaching. This interdisciplinary approach, I think, really helps in solving problems that are sort of at the forefront of condensed matter research.
Multimessenger astrophysics is a relatively new field of investigation, but one where the University of Mississippi is leading the way.
Multimessenger astrophysics is a relatively new field of investigation. It looks at light, gravity waves, and particles as messengers carrying information to us from astrophysical processes. It began as a field in 2015 when the LIGO experiment made the Nobel Prize winning discovery of gravity waves. And from that point forward, we've been able to observe the universe with gravity waves in addition to the light waves that we've always been able to see with our eyes and our telescopes.
I'm proud of the work I do here because we are able to collaborate with people from all over the world and all over the United States. It also, here at the University of Mississippi, we have a lot of opportunities to go out and talk about our work, doing different outreach. So I think this is, a great community, especially for a graduate student.
I'm fundamentally driven by trying to learn more about the universe. So I think that's what we're doing here. That makes me proud of the work that we're doing.
The annual APS March meeting provides an exciting atmosphere to share new discoveries, establish new networks, and contribute to the expansion of human knowledge.
March meeting chair Paul Chaikin has been hard at work planning for the week and joined us right now in the studio with a preview of what's in store. Welcome.
Thank you.
Thank you so much for coming to talk to us this morning. We're finally here. How does that feel for you?
Well, seeing the crowds and stuff coming in from the airport is great. This is my 55th March meeting, and the crowds haven't dimmed in those years. And if anything, they're more exciting.
Give us a flavor of some of the work that's gone into planning for the week.
Well, we had to wait for the Nobel Prize announcements to happen, and then luckily, as it turns out this year, we had the Physics Prize, which was a natural for this meeting, but also the Chemistry Prize had a lot of physics in it. And indeed, what was amazing is the Peace Prize went to a former Sakharov Prize winner from APS, a physicist.
You mentioned that the crowds have not dimmed over your years here. We're expecting 13,000 attendees.
They're bigger, but the excitement is there.
That's wonderful. So with that many people expected here in Minneapolis this week, what can they expect? What do you have in store for them?
Well, the main thing, as I say, is just going to be the presentations of young, especially young, new physicists talking about their discoveries. That's always the most exciting, but we prepared an additional program that's really exciting. This afternoon we have a Nobel session honoring the Nobel Science and also the Peace Prize winner. And on Thursday we have the Kavli session, which this year is on far from equilibrium physics, from cosmos to cells, to the kitchen, to quantum. So covers a vast range, even what cooking is like in your home. We have a play on Wednesday on Lisa Meitner, who didn't get the Nobel Prize that she deserved, to share with Otto Hahn. So it's going to be an exciting week all around.
I'm looking forward to that kitchen part that you referenced. We're talking chocolate, Stephen.
You're talking chocolates.
This is also a very exciting year. We need to point out that this is the 125th anniversary of APS. Have you incorporated that milestone into the program at all?
Indeed, that's what we used to get our great speakers, and we said you're going to be presenting at the 125th anniversary, and it's a great time to look forward to what the next century and a quarter is going to hold in store for us.
So we've been coming to this March meeting now for over 10 years, and you've been coming for 55 years.
Yes.
So what is it that brings people back year after year to the March meeting?
Well, it's the new discoveries. There's by the middle of the week, you'll hear a buzz in the halls of what people have decided, is really the hot new items discovered this year. But I could even hear some of it coming in coming in from the airport. People were really excited, talking with each other, and terrific.
It's been great chatting to you, and thank you ever so much for taking the time to do that, and we're really looking forward to the week, so thank you.
It will be a great week.
Next, we step into the dynamic Narong lab at UCLA. Witness how their groundbreaking research is not only advancing theoretical knowledge, but also paving the way for practical applications.
Quantum information science, quantum technologies, and I use those words interchangeably, are really able to confer superpowers on technologies that we are interested in our daily lives. Our lab's vision for scientific innovation is really about bringing quantum science and quantum technologies to life. We're very focused on how quantum science, fundamental discoveries in quantum science, can impact people's daily lives. To us, quantum science and technology includes quantum sensing, includes quantum computing, as well as quantum networking. We think of this work in fundamental quantum science as an investment that is shaping the next era of quantum discoveries.
The Narang Lab contributes to the future of theoretical physics by engaging in cutting-edge research, collaborating with experts in the field, and exploring innovative ideas. This knowledge is very instrumental for fundamental research in physics and even in chemistry.
Type 1 Energy is revolutionizing the nuclear fusion energy landscape with its top-tier talent and cutting-edge technology derived from scientific fusion machines. Let's see how they are spearheading the shift from exploration to electrification.
In order for us to achieve our goal to design and build a fusion power plant, we need to think beyond traditional core focus on fusion science, and that really means we need to move beyond the traditional boundaries of the types of people that would work in a fusion company.
I think the stellarator is really key here. That is the most robust, has the cleanest and clearest path towards fusion energy. Once we make it work, we'll have an energy source that just produces electricity and heat 24/7, requires very little in terms of fuel, and produces very little in terms of waste.
In Type 1 Energy, there's this culture that no idea is a bad idea, that really fosters a environment that allows you to be a better, more creative engineer. You're challenged, you're pushed to think outside the box, be more radical, and be more creative in how you solve these problems that have been a problem for decades now.
APS TV is talking with attendees, asking, what do you hope to get out of this week?
Yeah, it's my first APS March meeting, and I was very excited to come to the United States first. I'm a physics student. I want to search some new kind of technology which is developed in the recent times in my field, and I want to learn and experience a few new things throughout this conference.
This is the biggest meetings for physicists, so hopefully I would meet new people, find a new collaboration with other people, and especially also presenting my work.
This week I'm going to present my research. I try to share our research to everyone. Of course, I also want to learn with a lot of people.
Making a lot of connections and making a lot of connections to the future, and learn what kind of tools I can use on my research. When we are in the place when everybody knows a lot of physics, you can't be talking with the person that will be able to solve your problem here. It's going to be a fun time here, sure.
Building on a rich history of achievements, Rice University's Quantum Initiative leads pioneering research in quantum science. The initiative brings together over 40 faculty members across disciplines to explore quantum protocols and algorithms.
The Rice Quantum Initiative isn't just a research center, it was really a full stack approach to quantum science here at Rice University. It covers everything from the quantum hardware to the experiments on new materials for that hardware, ways to connect them together, and the software to use these and bring them to applications. It includes more than 40 faculty members in different areas of science, engineering, and encourages collaboration between all of them.
When everyone looks at the same thing from a different lens, we shorten the time of understanding and the effort of understanding because everyone brings insights for the same thing we have been thinking about.
Quantum provides the fundamental insights that we can then use to have breakthroughs in different areas of life and creating computing tools that can then solve these most pressing problems of our society today.
The results of those interfaces will bring new ideas to engineers to build applications of these systems, and we hope to bring these out into the world in ways that can impact society.
Staying in Texas, to the Wooten Center for Astrophysical Plasma Properties at the University of Texas. There, we explore the uncharted realms of astrophysics as we bridge theory and reality, testing radio-atom interactions in dense plasma environments to refine our cosmic understanding.
WCAP stands for the Wooten Center for Astrophysical Plasma Properties.
The center was born from the mind of Alan Wooten. Our goal is to measure in the laboratory material properties such as the opacity of matter at the actual conditions found in the cosmos.
We measure things nobody's ever measured before. We're able, because of the Z machine here at Sandia, the NIF facility, National Ignition Facility, we're able to do experiments that are at parameter, under cosmic conditions, for the first time in the history of astronomy. We explore these conditions that we find in the cosmos, the cosmically normal conditions, as Greg Rockow likes to say. We realize that we're looking at something no one on Earth or anywhere has ever understood before, ever seen before. We're creating conditions that are unknown. And so you learn something about the universe that no human being that's ever lived before has ever known. And that is an intoxicating and addicting thing. Makes science fun.
When it comes to getting kids interested in science, you can never start too early. That's why APS is hosting their first ever Squishy Science Sunday to get kids excited about physics. Let's check it out.
It's just very interesting to learn how the world works.
A lot of fun things to do. I made this.
It's just really fun and you get to learn more things.
You're here today at Squishy Science Sunday, the very first event of its kind, hosted by the American Physical Society's March meeting. It's a day for the public to come in and see the kind of science we do. This is what's happening at the frontiers of research. You don't have to be an expert to understand and make sense of it.
We were learning about non-Newtonian fluids and polymers. So non-Newtonian fluids, when you hit them really hard, and when you apply a lot of force, they're hard, but when you just move slowly, they're just a liquid.
I'm a science teacher, so I learned about it through the Minnesota Science Teachers Association. I think that's just awesome to bring people in for something like this. I like the idea of getting to interact with actual scientists.
So you put glue in this bowl and then you put as many colors as you want and it expands and it looks really cool and all the colors mix.
It was a lot of fun. The kids saw it and saw the activities and wanted to join in. It gets them to kind of continue their learning, get in and get their hands dirty.
Put these things on, you separate it a little bit, and then you pull it apart, and it made a little pattern.
I think science is super important. I think the creating and the exploring was just something fun we could all do. They're all at different levels of science, so it was something we could do together. I think this is awesome. I think it gets families out. I think it keeps kids interested and in different ways and hands-on ways.
We want people to be able to understand the world and think critically about things that are going on. So the younger we can get them started, the better they are at thinking through and being able to answer their own questions.
So there are scientists here who are doing things that will affect the climate, that will affect energy, that will affect how to make life more livable for everybody around them. This is a society that's not just for the experts, but we really care about the science, we really care about the world, and we really care about making a positive impact on the world.
Time now to embark on a scientific journey with Carolina Physics and Astronomy, a beacon of excellence in research, education, and public engagement, tracing its legacy from pioneering observatories to groundbreaking discoveries in quantum gravity and beyond.
Situated in the heart of the Research Triangle Park in central North Carolina, Carolina Physics and Astronomy is a prominent hub for the perpetual pursuit of understanding the mysteries of our universe and understanding of the questions and challenges of our everyday lives.
Understanding neutrinos is really key to understanding fundamental physics because they're the one solid piece of evidence that we have that what we call the standard model doesn't explain everything. And so there's sort of a loose thread that we can tug on to unravel some of these mysteries.
Where do the matter actually come from? How do they interact? How does the cosmos come to be? And whether there are any living life out there.
NanoQT is Japan's pioneering startup to develop quantum computing hardware based on cavity QED. Their unique technology, integrating neutral atoms with a nanofiber cavity, offers a hybrid system of atomic and photonic qubits suitable for quantum network applications.
Our mission is to develop a scalable quantum networks through a hybrid systems combining neutral atoms and photons with a nanofiber cavity platform.
Cavity QED, with its unique hybrid system of atomic and photonic qubits, offers advantages in distributed quantum computing.
By using our nanofiber processing technologies, we can realize a security system with nanofiber cavity directly connected to the industry standard fiber network. Ytterbium-based qubit can couple with traveling wave telecom photons via the nanofiber, paving the way for applications integrated with optical fiber networks. Our quantum processing unit represents a hybrid system of atomic and photonic qubits achieved by integrating neutral atoms with a nanofiber cavity.
We aim to develop proof-of-concept quantum repeater by using ytterbium atoms at the telecom band wavelengths.
Washington University, given its strengths in biology, biomedical, and life sciences, including plant science, is a unique position to develop and apply custom-tailored quantum technologies and advanced instrumentation in these research areas. The Center for Quantum Leaps will nucleate new collaborations across 3 schools and will inject transformational technologies.
The Center for Quantum Leaps is an interdisciplinary center, and the purpose of the center is to connect those working in quantum technologies to the scientific questions that different researchers are pursuing at Washington University. And the goal is to find areas where quantum technologies can really help drive advances forward in different research fields. Our center really focuses on developing those quantum technologies, expanding our understanding of quantum technologies, but also finding new places where those technologies can have impact.
We've created a center to really see what we can do with quantum sensing. What can we use this for in material science? What can we use this for in biology?
Here, what we're thinking about is quantum information, quantum computing, and we've talked about quantum sensing here at Washington University. These areas are ways where we can enhance scientific discoveries by using and harnessing the special properties of quantum mechanics to do things that we hadn't even envisioned a decade or 2 ago.
And with that, it is time to say goodbye for this first day of APS TV. Remember, if you missed any portion of today's episode, there are plenty of ways for you to watch. You can find the latest APS TV episodes airing on the TV screens here at the Minneapolis Convention Center, on the in-house channels at several select partner hotels, on the March Meeting website and on the virtual platform, on the March Meeting app, on our YouTube and X social media channels, or you can scan the QR code here. We got started this week with Stephen's amazing sit-down with one Nobel laureate, but he's actually just getting started, isn't that right?
That's exactly right, Orcha. We've got so much more in store for you this week. We'll dive even deeper into the research of attosecond pulses of light with Nobel laureates from the Ohio State University. I'll speak with Pierre Augustin. Plus, we'll continue to introduce you to the incredible organizations breaking new ground in physics research from around the world. Don't miss day 2 of APS TV right back here tomorrow. You won't want to miss a beat, and we will see you then.